So for section 2.6, we're going to be talking about ratios and percents. We've seen the idea of ratios before because we've really dealt with fractions. So when we say A to B, another way of writing that is we can use this kind of colon, meaning A to B is a ratio, but we can also make it a fraction, A over B. The same idea. So we're going to take a couple examples here, and we're going to take the ratios they've given us and write them as a simplified ratio. The ratio of 5 hours to 3 hours. Well, I could write that as 5 to 3, or with the colon, 5 to 3, or as a fraction, 5 hours, right, over 3 hours. That doesn't really simplify, so we're going to leave it like this. But here's another thing. Well, what if I had, and I knew somebody had worked 6 hours in 3 days? Well, I could write that as 6 hours to 3 days, or 6 to 3. But when I make it a fraction, I end up with 6 hours over 3 days. And that can be simplified. The 6 and the 3 can basically be reduced by 3 so that we get 2 hours per 1 day, or 2 hours per day. Now that may not be the exact amount, but that would be kind of a simplified ratio so that we can see if they worked 6 hours in 3 days, we would assume maybe 2 hours over each day. How do we use those? Well, here's an example of, I'm looking at 3 packages. I can get an 18 ounce for $3.49, 28 ounce for $4.99, or 40 ounce for $6.79. We can set these up as 3 ratios. What you do need to decide is, what do we want to set up? Do we want to do ounces per dollar or dollars per ounce? Well, if you go to the supermarket, nowadays actually a lot of the supermarkets will give this to you. But if they don't, or if you are going to do a supermarket that doesn't, or when they used to not do it, what you would do is you could take the price and you could figure out, let's compare these 3 sizes, our small, medium, large size. We could compare them by doing dollars per ounce. And so I would take this price and say, okay, as a fraction, that's $3.49 per 18 ounces. And then what you do is you could divide that 18 into the 349. Now that's not going to be super easy, but remember we have the technology. So I can do 349 divided by 18, and I get 0.1938. Now I'm not paying 19 cents and 0.38, but so we're going to round it. This is about 19 cents. So and this is the same thing the company is going to do when we're solving this. So this is approximately 0.19 per 1 ounce. So it's about 19 cents per ounce. If I take the $4.99 and I divide that by 28 ounces, so I'm going to do $4.99 divided by 28. That would be $4.99 divided by the 28. And this one's a little cheaper. 17, rounded up to about 18 cents. Per 1 ounce. And then last, what if I get the 40 ounce? Am I going to be saving a lot of money? Well, $6.79, divide that by 40. So $6.79 divided by 40. And the Costco brand saves us, well, 0.169. So that would round to about 17. And you're like, well, of course, right? The bigger one saves you money. Well, not always. Maybe the smaller one would be on sale, and that might change this ratio. Because these are really not that far off. And so keep this in mind, right? I'm buying peanut butter, and maybe I'm just shopping for me. I don't know that I need 40 ounces of peanut butter. That peanut butter might actually go bad, and I may lose money. Because there's about a penny or two between the highest and the lowest, And so it may be worth it for me to get the smaller size. We always buy the bigger size going, oh, we're saving all this money. Well, you never know. So that's why we check it. You divide the price by the size, and we can get a cost per ounce, cost per whatever. When I solve proportions, the idea is we're going to be setting up these fractions, like a fraction set equal to a fraction. One of the things I'll hear people do on this is they'll say, oh, you just cross multiply, the B magically travels up to the C, the D travels up to the A, and we end up with AD is equal to BC. And that doesn't bother me, if that's something you already know, but what does bother me is that people treat this like it's a magic trick. See, what we really did is we cleared out these fractions by doing what? Well, I multiplied both sides by a D. I'm going to write this below because this is kind of one of those facts that you should know. But what did we really do? Well, if I multiply both sides by D, on the right side, that D would cancel out. That didn't really clear the fraction on the left side. So I'm going to multiply both of those sides also by B. And this time the fraction on the left would clear out. So what do we end up with? Well, the A with the D. And on the right side, the B with the C. So that's really what you're doing when you're cross-multiplying, is you're clearing out the fractions. Okay. So we're going to use that here for example 4. If I wanted to solve this, I can cross-multiply. I can multiply both sides by the 9. It basically multiplies the 9 up to the x. I can multiply both sides by the 63. It's going to multiply the 63 up here. We end up with 5 times 63, 315, is equal to 9x. We've solved these before. They're not that hard. To undo the multiplication, we divide both sides by 9 and get that x is equal to 9, 18, 27, so how about 35? Some of you are looking at this going, I would have done that differently. Okay, let's talk about that. There's nothing wrong with you seeing these two fractions are supposed to be equivalent, right? And so you're like, well, wait a second, isn't this 9 is now 63? Isn't that just 9 times 7? I go, yes, it is. You know, well, if I had to multiply the bottom by 7 to make it a 63, I'd have to multiply the top by 7 to turn it into whatever x is. So what do we end up with? Is we end up with 35 over 63 is equal to x over 63. And you're like, well, duh, x must be the 35. There's nothing wrong with that. It won't always work, but when it does, please feel free to use logic. I'm never going to discourage you using logic to solve a math problem. Problem is this: how do I change a 4 into a 6? That's not going to be an easy way, right? How do I change that 6 to a 4? That's not going to work. So we need to be able to eliminate the fractions here. Cross multiply. The 6, really I'm multiplying both sides by 6. This one goes away. It moved up here. I'm multiplying both sides by 4. This one goes away. It moved up here. So what are we left with? 4y is equal to 7 times 6. And then to undo the multiplication. Now 4 doesn't go into 42 very nicely. You can make that a decimal. That wouldn't bother me. If you made that 10.5, I'd be fine with that. If they want your answer as a fraction, we do need to simplify 42 divided by 4. They're both divisible by 2 to give us 21 over 2. Either one is fine with me. Depending on what they want, you're going to need to know how to do one or the other. Let's do one more that's not one that we can do easily in our head. A over 24 is 15 over 16. Actually, we got a couple more, I guess. We're going to multiply the 24 up to the 15, the 16 up to the a. So 16a is equal to, you should be able to do 24 times 15 in your technology. Check that out. I think that looks like it's 240 plus 120, so let's say 360. Last, I'm going to divide both sides by 16. Now, I don't know this off the top of my head. I don't know what this decimal is. It's, I think, 20-something. But I could simplify. Both of these are divisible by 2, because I know they're even. would give me 180 over 8. Well, they're still even, so I could divide them both by 2. Gives me 90 over 4. They're still both even, so we could divide them by 2. It gives us 45 over 2. 2 goes into 45, 22.5 times. So you can either write 45 over 2, or depending on the situation, 22.5. Here's another one. It's not as bad as it seems. I actually have a couple of these, but I want you to see how this would work. The 2 multiplies up to the, not just the z, it multiplies to the entire group. The 3 multiplies up to just this z, so that's nice. We end up with just 3 times z. But the right side becomes 2 times z plus 1. You have to know to take that 2 and we distribute that, so that 3z is equal to 2z plus 2. I've got a z on both sides, so I do not combine them, move one of them, and we end up with z is equal to 2. You could check that out, kind of fun. I can stick the 2 on the left and get 2 divided by 2 is equal to 2 plus 1 over 3. I'm pretty sure 1 is equal to 3 over 3. 1 is equal to 1. Same process here, but this time the 4 distributes and the 3 distributes. So this ends up being 4 times p plus 3, and this one ends up being 3 times p minus 5. So up here, when the 4 distributes, we have 4p plus 12. And over here we have 3p minus 15. Isolate the variable. We're going to move the 3 so that p plus 12 is equal to negative 15. Undo the adding with subtracting so that p is equal to negative 27. Here's another interesting application. Leanne pumps 5 gallons of gas. The display shows a price that reads $23.20. She finishes pumping the gas. It's now $67.28. How many gallons did she pump? Now, in the reality of life, you can look and you can figure it out, but what if at the end she just took the receipt and it just had how much it cost? Well, you should be able to figure out how many gallons she put in here by setting up ratios. Would we do dollars per gallon or gallons per dollar? Well, more often than not, the ratio, when we're talking about paying for gas, is dollars per gallon. So right here, this $23.20 matches with 5 gallons. I can say it was $23.20 for 5 gallons. And that should be equal to, how much do we spend at the end? $67.28 over, we don't know how many gallons goes here, but these ratios should be the same. The gas all of a sudden didn't change price while you were pumping. So if it's 23 and 20 for 5 gallons, then 67 and 28 should be for X gallons, we don't know. How are we going to solve this? I'm going to multiply the 5 up to the 67, the X up to the 2320. So we have 2320 times X is equal to 5 times 6728. Let's use some technology. 5 times. So 336.4. Double check my work. And then last, to solve for x, since it's being multiplied by that scary looking decimal, divide by that scary looking decimal. So 336.4. Divided by 2320. So 14.4931 so about 14.5 gallons. Our last big thing we're going to talk about is percents. See, there's a couple ways of dealing with percents. They, in the book, just say amount divided by the base is equal to percent over 100. I remember that this was taught before. If you were comfortable with the word is over of, and then percent over 100. That is not my favorite way to solve these. The main reason we teach this is because this makes these questions very solvable without technology. But when are you going to be dealing with percents in real life and not have technology? Okay, so yes, there are some times that I use this idea of setting up a fraction, but here's what I recommend. Learn how to read these and translate them into an equation. For instance, if I take 20% of 5 is what number? Well, 20%, I can translate that. If I'm going to find 20% of something, I'm going to multiply it by a decimal. You have to know how to change that percent to a decimal. The decimal moves back 2 times, and so it's going to be 0.2. Of translates to times. 5 is 5. Is equals, and what number? That's what we don't know, right? X. So what I can do now is I literally can just do, what is 0.2 times 5? %20 of 5 is 1. This is what I'm using. If I've got something that's $5 and I know that it has 20% off, I am not sitting there and setting up an is over of to find what that percentage is. I'm pulling out my phone and I'm taking 5 and I'm multiplying it by the decimal 0.2. And that's a quick way of finding percent. Why do we do the whole is over of? Well, this should work. The is the x, right? What we don't know. So x of 5 goes down there equals percent 20 over 100. If I cross multiply this, I get 100x equals 100. Divide it, and x equals 1. The answer didn't change. The difference is, on the right, that's easier to do in my head. It's easier to do on pen and paper without technology. But like I said, more often than not, when are you not going to have technology? So feel free to use whatever you're most comfortable with. Find 50% of 600. If you want to, set over the 15% goes 15 over 100%, and the 600 is the whole, or the of, that we're looking at, and we can put our x there and solve it. Doesn't bother me. What would I do? Well, what is 15% of 600? 15% as a decimal is 0.15. Of means we're going to multiply that by 600. 15% of 600, I go to my technology and do 0.15, 0.15 times 600, and that would be $90. I assume we're talking money. So this should be 90. Sorry. Okay, let's keep going. 32% of what number is 64? Well, they changed it up a little bit. But I can still go. All right, let's start with those of you like your is over of. 32%. 32% over 100 of what number? The thing we don't know is x. That's the of is 64. So you can fill it in that way, cross multiply and solve it. Okay? What do I like to do? 32%, 0.32 of times x equals 64. How would you solve this for x? Well, since it's being multiplied by the decimal, we divide by the decimal. Can you do 64 divided by 0.32 in your calculator? I sure hope so. And you should get that x is equal to 200. One more, and then we're going to look at some more word question applications. 90 is what percent of 360? Well, 90 is, for those of you like that, 90 is what percent? This time the x is the percent. So it's the percent over 100. And the of, or the whole, is the 360. If you like that, please feel free to do it that way. What am I going to do? 90 equals what percent? X times 360. To solve for x, I'm going to divide both sides by, and I get that x is equal to 0.25. Now be careful, because 0.25 is a decimal. That's not the percent. We have to be able to go from a percent to a decimal, but here at the end, if I want to turn this back to a percent, the decimal moves back twice. And I get that x is equal to 25%. You're like, well, that seems complicated. I wouldn't want to pull out a piece of paper and do that. I understand. And this is where I think of this as 90 of 360. I would just go to my calculator and I would go 90 over 360. I would get 0.25 and could turn that into 25%. Okay? So as you practice this, you can actually learn how to do these very quickly without pen and paper. But, you know, make a choice. Figure out what's going to help you get it right for the test. We will have some percent questions. A DVD has a regular price of $18 and it is on sale for 22% off. Find the amount of discount and the sell price of the disc. Some of you are going to set up. Now the 18 is the regular price. Okay? So that would be our 18 is 22% over 100 of what? That's an option. That's not my option. That's just an option. I know that if it's $18 and it's 22% off, I could find what is 22% of 18. 0.22 times 18. And I've got technology to do that. And I could very quickly go, what is 22% of 18? 396. Sorry. That is not the answer, right? What is the question? They said, what is the discount? Well, it was 22%. So we got $3.96 discounted. What's the final price then? Well, it's the initial price minus the discount. So it would be $18 minus $3.96 should give us $14.04. You can't tell me. This is one of those things that really bothers me because I have some people go, when will I ever use this in life? You should be using percents all the time. Markups, discounts. When you buy stuff, you get charged tax. One of my favorite examples of this is I have my father-in-law. He is not a mathematician, but he is what we call math literate. He's able to handle mathematics. And so he was going to the fair, and he purchased something, and it was $20. And the guy hit the little tax button, and all of a sudden it was $23 and something. And he goes, well, wait a second. That doesn't make any sense because the tax rate is 7% approximately, and that'd be about $1.40. And he goes, and you just charged me $3 tax. The guy goes, well, I hit the tax button, and this is what happened. He goes, well, no. And so here's this guy, and he's a music teacher. He's not even like a mathematician. And he's giving this guy a math lesson in the middle of the fair. And he goes, there's no way. That is not 7%. And so he sat down and figured it out. And basically the guy was charging like 14%. So the question is, was that an accident? Was it on purpose? I don't know. He might have just been doing it on accident. But basically he was charging these people And this was the last day of the fair, so over every day of the fair he'd been using that button and charging people an extra 7%. Where did that 7% go? Probably in his pocket. You cannot tell me this does not have life application. You should understand what percent markup, percent discount, or people are going to rip you off. You should know. Alright, enough of my soapbox. Newspaper ad offers a set of tires. They're $258. The regular price was $300. What percent of the regular price were the savings? Basically, how much did you pay? Well, a couple ways of doing this. You could say, well, I paid $258 out of 300 is equal to what percent over 100? That's fine. I would just take the part, the 258, divide it by the 300, and get that as a decimal. 258 divided by 300. I'm not doing that one in my head. .86. Well, that's not a percent. But if I move it twice, that means 86%. If you solve this on the left, you'll get 86%. So basically I paid 86%, which means there was that's the answer, that's all they're looking for, but that means there was what percent of a discount? Well, instead of 100%, I paid 86%, so that means I got a 14% discount. This is useful. If there's something and it has a 14% discount, and this is how much I pay, I should be able to verify my discount and make sure I'm not getting ripped off. Television set with the regular price is $950 is now on sale for 25% off. What's the discount? What's the price? This is a life skill. I'm going to buy a TV, it's $950. They better give me, well, I'm just right off the top of my head, say that's about $1,000, so I should get about $250 off. A little less. I should be spending a little over $700 for this. If I go and I check out and they're charging me $800, we got a problem. If they're charging me $650, I may double check it, go, oh, that sucks, I just saved extra money. No, I'm not that type of person. I'd say, I think something's wrong, and then we look it up and they go, oh yeah, you know what, we forgot to mark the right percent off. Which means that salesperson could have maybe sold more TVs if he knew it was more than 25%. Alright, enough of my soapbox again. Can you figure out what 25% of that $950 is? Because that's your discount, right? 25%, 0.25 times $950. Check that out. 0.25 times $950. I should get $237.50 off. And that is our discount. That is not how much I pay. That's ridiculous, right? How much did I pay at the end? Well, the price minus the discount should be, I believe. Double check my math on that. Okay? So that would be the price after discount. So go through these. I tried to take out some of the ones that are a little more crazy. I really think all of these should have some good application. If you like the is over of, please feel free to keep using it. Feel free to ask me any questions if you have it. But that's our last section, so keep it up.